Welcome to Khetz Tutorials, and in this video I'll be covering question 12 from exercises A in James Stewart calculus. So we are asked to find the absolute value of 1 minus 2x squared. So we're going to consider both of the cases where A is positive and where A is negative. So if A is negative, we have to negate it, and if it's positive, the absolute value will just be whatever's inside the absolute sign. But now we're not given any conditions, so we don't really know what this is. It can be negative or positive, so we're going to cover both cases. So the first case would be that the absolute value of 1 minus 2x squared would be 1 minus 2x squared. This is if this 1 minus 2x squared is greater or equals 0, or would negate 1 minus 2x squared if it amounts or it results in a negative result. So this is when this is less than 0. But we are not done because there are quite a few things to work out. This is not simplified, and we don't really know about the range of x values which would make that positive, or the range of x values which would make this one negative. So let's work that out. Now let's extract this inequality, which is 1 minus 2x squared greater or equals 0. Now if you look at this, this is basically a quadratic function or quadratic equation, and you can visualize it in terms of the graph itself. So it's a graph which basically faces down. It looks like that, and we're going to find the roots and determine the conditions that satisfy this. So this is one way to look at this. Another way to look at it is to use the number line method, which is my preference. So to continue with this, you'd first have to find the critical values. And to find the critical values here, you'd solve this in a way. So to find the critical values, you'd imagine that you're trying to solve the roots. So that'll be 1 minus 2x squared equals to 0, something like that. And you have 2x squared equals to 1, and x squared equals to a half. And now your roots or your critical values would be plus or minus. So x would be plus or minus 1 over square root of 2. So plus or minus square root of 2 would basically give you 0, but this is not what we're looking for. We're looking for the regions where we have this expression as a positive result. So basically, if you substitute a number into this expression, we basically expect to get a positive answer. So using the number line method, you're going to have your critical values starting with the negative 1 over square root of 2, and the positive 1 on this side. So these are your critical values. At these points, this is where you have 0. So this would be part of your solution, at least this one, right? Because if you substitute this, you're going to get 0, so that'll be part of your solution. If you substitute this, you're going to get 0 as well, that'll be part of your solution. But now I want to determine the parts which are greater than 0, or in other words, the parts which evaluate to a positive number. So you can substitute any number in each of these regions. You have 3 regions. The region that comes before negative 1 over square root of 2, the region in between, and the one that comes after 1 over square root of 2. So if you pick a number in each of these regions and you evaluate it in the expression, it basically gives you an idea of all of the values which are in that range. And here's an example. So to the left of negative 1 over square root of 2, I can pick a number, let's say negative 2. So negative 2 is somewhere there. And that should tell me whether the values here are negative or positive, or they evaluate this expression to a negative or positive. And if I pick a value there, I can pick 0. So if I pick 0 there and put it in there in place of x, I'm going to get 1, which is positive. So in that region which is in between, I'm going to get a positive result. If I pick a number which is outside the region, let's say 2, so on this side, and I put it in there, so that will be 4. 4 multiplied by 2, that is 8, but that's negative. So 1 minus 8, so that'll be negative. So on this side, I have negative values. So if I substitute any of these values, it will amount to a negative number. But if I substitute any of the values which are in between these two numbers, it will result in a positive number. If I substitute a value which is in this region on this side, let's see what happens. If I substitute negative 2, it doesn't matter that it's negative, still amounts to negative 8 there, 1 minus negative 8, so this side is also negative. Then now I have to answer the question, which region will result in a positive result, or where will I get positive numbers, or those which are equal to 0? And if you look at this, this is only this region. So that is your region. So between negative 1 over square root of 2 to 1 over square root of 2. And I include these parts because it's greater or equal to 0. So here, the expression is equal to 0. There, the expression equal to 0. But in between, the expression is greater than 0, so it's positive. So now, to now finish my answer, the absolute value of that will be 1 minus 2x squared if x is between negative 1 over square root of 2 and 1 over square root of 2. And it's important to include the equal sign as well, because these are part of the solution. Okay? Then, the other part, this is where 1 minus 2x squared is less than 0, or where the expression is negative. And these are the regions where that is negative. And for that portion, we'd have 2x squared, so just expanding this part, 2x squared minus 1, and that is if x is to the left of this. So x is less than, and it's not equal to in this case, because if it were, then it would not satisfy that. So x less than this value, or x greater than this value. So this region to the left of that, and this region to the right of that, will basically give you a negative answer if you substitute any of those values into there. And that is how you answer that question.